You are welcome to my YouTube channel. In today's video, we'll talk about generator expressions. They are also referred to as lazy iterables. A generator is a function that returns an iterator which produces a sequence of values when iterated over. So what a generator does is that it returns an iterator. We have seen this generator expression when we talked about tuples, list, and I will leave a link of that video towards the end of this video. But specifically, generators are defined by this. You have as a function, you have a generator name, the argument, and then the keyword yield, okay, is used to denote a generator. So yield something. You can ask what could be the possible uses of this generator. I'll give you a typical example. If you happen to load large amount of data, okay, into memory while you work. Instead of loading them once into memory, it's much more easier and faster and memory efficient for you to use generators to load them. Let's see examples here. I have a function called square num that takes in an argument num. So for I in range 1 and num, I want it to yield I square. Or you can say for n, n in and a yield the square of n. If we run this, we already have a generator. So if I want to print the square of 20, so range of numbers from 1 to 19, okay? Range of numbers in 21 to 20, which is 1 to 19, one less than 20. What would that give us? Mind you, if you don't print a list on it, if I remove this and just print the square of 20, what will it give us? It gives us the generator expression. To remove the generator expression, what do? We simply call a list on it. If you call a list on it, it gives you a list of everything. This is one way of doing it. Another way of doing it is to do what now? Is to iterate over it. Okay, now let's call squares equals square number of 30. Okay, and then I want to obtain each value so that for every time I want to get the square of each number in the range of 30. So I'm calling this function again because of this yield will return a generated expression. I will now loop through the iterable, lazily, and then get each of what now each of the values. So if you run this and print, we can see it prints 1, 2, 3 until 29. Okay, until 29. If you put in, if I actually want to have done this, I will have done range of n plus 1. So that if I run this and do this here, it prints this until 20, 400. And if I run the next one, it prints this until what? 30, 300. Each of these depends on what exactly you want or is your preference. If you want the last number to be included, you have to add plus 1 to it because of Python indexing. So next, let's look at another function here. Remember the range, I can define my range. Here I have a range of n, right? And I will start with a value of 0. So I use a while loop here. Y value is less than n. So I keep iterating, looping until it hits the false condition when value is greater than n. While is that yield value. And after that, increment the value by 1. So if we run this, what do we have? And then now we say for value in, let's say for val in range 6, print val. Okay, what would that give us? It prints it 0, 1, 2, 3, 4, 5 until, because we say yn value is less than n. So y val is 5 is less than 6. It will return val. Okay, we can as well still loop through it and square it. Though we have not written a square of it, but we can loop through it and then square the value. See, it allows us to loop through the value and manipulate the output. We can also have what is known the Python generator expression. Instead of using the generator expression as a function, we can also write an expression for it, and the syntax is using the brackets, okay, just like a tuple. So we have expression for item in iterable. When you write this, it is called generator expression, not tuple comprehension, unlike list comprehension. So I can come here, what I've written as a function, I can simply write them as a generator that says squares, I squared for I in range 1 and 10, or for I in range you know, 1 comma 11. And then if I print squares, what would that give me? If I print squares, you see it gives me what now? Print squares gives me a generator what? Expression. I intentionally printed squares to show you that it's generator expression. Then I can now look through squares, and then I can print each of the values in squares. Okay. Now you can also call next on these squares. Now, if I don't want to look through these, let me comment this out and comment the next one out. Right? I can simply do next because it's a lazy iterable. You can get the next of each item until the last item. After the last item, it returns, stop iteration error. So I can get next of what? Of squares. If I run this, what will it give me? It returns 1. Mind you, we can remove this. If I run it again, 1. So you can keep doing nest and nest and nest and nest and nest like that. Nest of squares again, 4. You can see it. You keep doing nest again. If I run again, of course, the nest is 4. I can keep printing nest and nest and nest and nest. Let's see, nest 36. Let's keep doing more nest, more nest, more nest. I want to show you what happens when we have exhausted all the nests. We are still doing more nest, around 100. I've gotten almost there. See, after the last value and you do next, it raises what? A stop iteration method. What is telling you that we have exhausted all the next. You have called every item with next and it has exhausted. So is that you call each of these generator expression, either you define them as Python generator expression or as the earlier function, we can call next on them. So we just come here and uncomment this and also come here uncomment this. We can run again. It prints, of course, all of this. Now notice that when I called next on squares, it gave me 4, right? By the time I print for I in squares, it start printing from what? From 9, because I've already popped the next value of squares. So we start printing from the next available value until the last value. One, they are easy to implement. It is used for memory efficiency. It's also used to represent infinite string. Also, we can use them in pipelining generators. So generators are very, very useful in Python and in code development. Here, if you look at this function here, I have all even. Okay. What happens here is that if you run this code, it runs infinitely because we said n is 0, y n is true, yield n, and n, increment n by 2. So it returns, use n is equal to 2, 3, 4, 5, 6, 7, 8. It keeps running and running and running and running. So here you can see how I've used that to represent infinite stream, but in a memory efficient way. But you keep to do this, it keeps running and running and running until you terminate the script. So I will not run this code. We can also use generator expressions to also what now? Get our Fibonacci numbers or called the Fibonacci sequence, which is represented here as 0, 1, 1, 2, 3, 5, 8. The next item after the first two elements, the next item is some of the preceding two items. And I've shown that they're using this spiral. This spiral shows exactly the Fibonacci sequence. So the Fibonacci sequence is actually used to construct the spiral. Starting from 0, 1, 1, go by 2, 3, 5, 8, 13, 21, 34, and so on and so forth. So we have seen this spiral occurring what in nature, in plants. Now, let's see how we implement that in Python. So here again, I call define Fibonacci of number and I assign x, comma, y to 0. So x to 0, y to 1. Of course, I don't need the index. So I say for underscore in range num, uh, assign x to y and let y be the sum of x and y. And then yield x. Okay, this is the Fibonacci. So I've written it in a different way, like we have done previously. Okay, but here using generator what expression. So next, I will now define square of number. I say for n in num, yield n square. Now, what do I want to do here is that now I want to square the Fibonacci number. Okay, I want to square the Fibonacci number. Let me also mention here that we can also use a closure. We can decorate this Fibonacci number. I think I should leave that as an assignment for you to decorate this Fibonacci number here to produce the square of the number. You can try that, and I'll post the results in my next video. Before I start the next video, I'll post the results. But you can as well do that. Let that be your own assignment. So now, how do I get the square? I just print a list of the square of Fibonacci of 10. If we run this, what happens? It prints the list. We have the Fibonacci of 10, the list of it, and the square of each of these Fibonacci number. I will leave you, like I said, to decorate this Fibonacci number as your own practice problem. I would post the solution in my next video. With this, we have come to the end of this video. Please like this video, share this video. If you are watching and you have not subscribed to my channel, please do well to subscribe to my channel. I will see you in my next video. Bye.